Acceleration is the change in velocity. This session we will divide it into two parts. The first part we learn the magnitude of acceleration. Before that, we learn velocity. Velocity is the change in displacement with time. Velocity is the change in displacement with time. And now acceleration is the change in velocity with time. Last time we learned constant velocity. Constant means it remains unchanged. Constant velocity because velocity is a vector. Therefore, constant velocity is the magnitude and the direction remain unchanged. Therefore, constant velocity is constant speed in a fixed direction. Sometimes we will see uniform motion, which means constant. And underline, change in velocity can mean several situations. It means change in magnitude, speeding up or slowing down, and even the direction. And change in velocity is exactly what is acceleration means. In physics, acceleration is not just meaning speeding up, but also include slowing down or changing the direction. Acceleration is defined as the rate of change of velocity. Before, we have learned velocity equals displacement over time. In physics, we will use S to represent displacement. And this time, acceleration is the change in velocity per unit of time. On screen, you can see this formula. A equal to delta V over time. Do you still remember what is delta V? In heat session, we have learned delta T. Delta means change in. So sometimes textbook write down delta V means change of velocity. And you can see the unit. The unit of velocity is meter per second. Show more clearly here. Meter per second. And the time, the SI unit is seconds. So overall, for acceleration, the SI unit for acceleration is meter per second, and we will write down ms minus 2. So underline, acceleration is also a vector. So now you have learned a few physical quantities are vectors: displacement, velocity, and acceleration. So these three, not only including the magnitude, but also the direction. It means that the positive, negative sign shown here for your answer, positive and negative, meaning the direction. Next page. Again, when we are saying average speed, average velocity, or average acceleration, average, we were talking about the total change. Okay? And the formula, again, for acceleration is V minus U over time. And this is exactly what I write delta V over time. Delta is the change of velocity. And here is V minus U. V is the final velocity and U is the initial velocity. Underline. Initial velocity means the velocity at the beginning. Usually from the question you can see In example 8, imagine David runs along a straight track. So he is having one direction, okay, just forward. He start from rest. From rest means at the beginning, his speed is 0. Therefore, we can write down the initial velocity u as 0 meter per second. And then he increased his speed to 10 meter per second in the first 2 seconds. And then he runs with a constant speed until 11 seconds. After that, from 11 seconds to 15 seconds, he starts to decrease his speed uniformly to 5 meter per second. Alright, step by step. Question A. David's average acceleration in the first 2 seconds. On screen, we are finding average acceleration. So we have to calculate the total displacement and the total time. And in part A is talking about 2 seconds. Think about a timeline here. This is the timeline from 0 second to 2 seconds. What's happening is at the 0 seconds, his speed is 0 meter per second. And at the first 2 seconds, he will increase his speed to 10 meter per second. So here, in these 2 seconds, he is undergoing acceleration, which means speeding up. And by the formula, acceleration in the first 2 seconds, A equal to the final velocity, which means 10 minus the initial velocity. This is v, this is u. So, and the time taken is 2 seconds. The answer is 5. And remember, the unit is meter per second square. And this is exactly the solution here. And remember, the positive sign is hidden here. And the rest, the exercise, the part B is left for your exercise. Part B, you have to notice that because from the time at 11 seconds, is the beginning, is the initial speed. Okay, therefore, here on screen, t equal to 11 seconds, the velocity is 10 meter per second, and at last is 5 meter per second, and therefore you can find the answer here. The negative sign means slowing down. And next, underline just take a look what is acceleration means. Accelerating at 2 meter per second means for every seconds. You can see from time 0 after 1 second for every second, okay? The speed is increased by 2. It is the meaning of increasing 2 meter per second in 1 second. And after another seconds, the speed increased by 2 for every seconds. And this is the meaning of acceleration, 2 meter per second square. Last but not least, underline, sometimes Even ourselves, our acceleration can be very large, even larger than a space shuttle. Alright? But it doesn't mean we can achieve a high speed. Why? Think about it. Here's another example. Remember the unit. Changing the unit into SI unit here. And that's all for the magnitude of acceleration. Next clip is about the direction of acceleration.